Okay, don't worry about this, just put skip. Okay, this isn't really going to help with anything. And here's what you're going to do here in this intro. There's 2 packets. So yeah. So write an equation of the function modeled in the table. You don't have to sketch a graph, cross that out. I don't need you drawing a graph. Only use graph if there's graph paper, which there's not. So that if you climb for 0 hours, you're at 1,127 feet. That's your starting point, okay? And then after 1 hour climbing, you're at 1,219 feet, okay? After 2 hours, you're 1,311 feet, and after 3 hours, you're 14,403 feet. Now, here's how you're going to write an equation. First, you're going to make that line. You're going to put 1,127 at the beginning, okay? Then you're going to put plus. Now, you have to figure out what you're going to be going up by every hour, but instead of putting X, and also that F right there, that F, you're going to put equals F at the top of the line, okay? Now, when you plus, you're going to find out what you're plussing by. I'll show you how to do that in a minute, but instead of putting an X variable, I want you to put an H variable, because you're trying to figure out how much you're climbing every single hour. So here's a way to figure that out, okay? You are going to start at the end of your table. And also, I'm putting a plus here because as I can see, I'm going up every time, okay? See, from here to here is up, up, up. So it's got to be something that you're adding every single time. Sometimes you're going to write a minus, okay, but not on this problem because I'm going up as the H increases. Okay, so we start at the highest number we have, 1403, and then you subtract the next number, 1311, okay? 92, so put 92 on right in between those two on that line. Now take the 1,311 and subtract 1,219, that's 92 again, okay? So I put that on this line, because between here and here is 92, 92. Now I take the higher number, 1,219, and subtract 1,127, and that's 92. So put that in there. So pretty much I found that every hour I'm adding 92. Okay, so plus 92H, and then you just write an equation out of that. 1,127 plus 92H equals F. Okay, and that's pretty much how that's going to work. Okay. Now in the next problem, you're going to make your line, you're going to put $52.07 right there, and you're going to put B at the top of the line instead of just putting a Y. Now here, if you look at what you're doing, it's getting higher, 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 so it's addition, okay? And to find out what you're adding, you start at the highest number you got, $55.94. Then I subtract 54.65. I got 1.29, okay? Then I take 54.65 and subtract 53.36. I got 1.29. Okay, then I take 53.36 minus 52.07, and that's 1.29. So that tells me what I'm adding every time, 1.29, but instead of writing X, I come over here and I see C, so I'm going to put C. So the equation is 52.07 plus $1.29C equals B. Now another thing I didn't mention the first one, you want to make sure you're going up by ones here, okay? If you're skipping numbers like from 0 to 3 to 6 to 9, that's another thing you would have to address. But here it's going by ones, so I'm good. By ones, I'm good, and that's that. Okay, then the last one. I start at 11.2, and up here I put equals G. Now this time I'm going down, okay? Throughout the table I'm going down. I can see that 11.2 to 10.2 to 9.2 to 8.2. So instead of writing a plus, you're going to put a subtraction sign. Now to figure out what you're subtracting, it's the same thing, but your highest number is now up here. Okay, so I take 11.2 because that's the highest number minus 10.2, and that's 1. Then I take 10.2 and subtract 9.2, and that's 1. Then finally I take 9.2 minus 8.2, and that's also 1. Okay? So I'm subtracting 1 all the way through there, but instead of 1x, we're going to put 1m because it's every mile. Now write that equation out. 11.2 minus 1m equals g. But we got a problem. Here it went 0, 1, 2, 3. 0, 1, 2, 3. Here, okay, it's not going by ones. Okay, it's not counting by ones. So what I need to do is underline the 1m, okay, not the beginning amount, the 1m. And I have to do a subtraction here. Okay, so I start with the highest, 51 minus 34 is 17. 34 minus 17 is 17. And then 17 minus 0 is 17. So I put a 1 minus 1/17 of m. Okay. So again, I didn't have to do that. I didn't have to put this on these ones because it was just by 1, 1, 1. Because putting a 1 under a number is kind of stupid. Okay. But if we're not going by ones, we're going to have to underline the rate of change and put what this is going by, which should be 17. Okay. Okay, now what you're doing on the next one is actually something quite easy. Okay. It says tell whether the equation is linear or nonlinear. It's an XY table. That means if I graph these on a plane, okay, graph the points. Don't draw this next thing, just watch. So like 0, 0 is the middle, you know. 1, 3, it would be forward 1, up 3, and so forth, okay? And then I would keep going. Now I got to decide if these points would go in a perfect straight line. And here's how I figure that out. The x's I don't worry about. I worry about the y's, okay? So I start at the highest number, just like I did on the last one. 9 minus 6, and you're always minusing. That's 3. 6 minus 3 is 3. 0 minus 3 is 3. So it's linear because it's the same thing every time. So linear. It's a pattern, 0, 3, 6, 9. Now if you look at the next one, again we're going to start at our highest point. 5 minus 0 is 5. And then I go 0 minus negative 3, just like that, is 3. So the pattern's been broken, okay? I got a 5 and a 3. Up here it was always the same thing, but a 5 and a 3 breaks the pattern, so that means it's non-linear. Okay, now the next one. Next one can throw some people off. Well, there's no highest number, so what's 5 minus 5? 0. 5 minus 5, 0. 5 minus 5, 0. That's linear because it's the same thing every time. Okay, so linear. Okay, and that's all you have. Here you're writing equations. Remember to watch, please, before you work. Remember to watch. Here that's going up, so it's adding. Here it's going down, so it's up, so it's adding. Here it was going down, so it's going to be minus. Okay. So when you make your lines, you want to watch out. Like here I see that's going down. That's going to be a minus, okay? Here I see that's going up, so that's plus. Here it's going up, so plus. To figure out the rate of change, that's when you go to the highest number and start subtracting, okay? Hopefully that made sense. And you got 1 through 3 and then 4, 5, 6, 7. Then you'll watch the second video. Or actually, I'm going to keep it on this video. Pause it and then go work. Okay. Okay, identify the domain and range of each relation. Determine whether each relation is a function. Now, these are all coordinate points of a graph. X, Y, X, Y, X, Y, X, Y, X, Y. Now, this is easy to do. Domain are all your X values. On a graph, the domain is represented by the X variable. So 3, 3, 3, 3, 3. Okay, and then your range are all the y's, 7, 8, negative 2, 4, and 1. Now look at your domain. The domain. Now you got to determine whether we have a function or not. Now, you're only concerned about the domain when you decide whether it's a function. You don't really even look at the range, just the domain. Do you have any repeat values in the domain? Yeah, I do have repeat values, so it's not a function. Okay, for it to be a function, you can't have any repeats in your domain. Okay, next one, you can just put D and R. So the domain are your x's. You got 6, 5, 1, and 7. The range, you got negative 7, negative 8, 4, and 5. Now remember, I'm just looking at the domain. Now here, do I have any repeats? Nope, that appears once, 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 then it is a function. Okay, next one, domain and range. And we're going to relate domain range to real life here in the next assignment that you do, which will be in the next video. So I got xy, 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 xy. So the domains are 0.04, 0.2, 1, and 5. The range, we got 2, 1, 5, and 25. So look at your domain. Do you have any repeats? No, 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 no. So then it's a function. Domain and range, okay? xy, 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 xy. So you got 4, 1, 0, 1, 4. Now, then the range goes 2, 1, 0, negative 1, negative 2. Okay, now look at your domain. Do I have any repeats? Yes, I do. I have 2 of them. I got 4 twice and 1 twice, so then it's not a function. That's how that works. Okay, the next page. Says the price of a pizza is $6.95 plus 0.95 cents for each topping on the pizza. You have to write a function rule that represents the situation. Here's how that goes, okay? All right, I'm going to make my line. Okay, I got $6.95 to start, and then it says plus 0.95. Oh, yeah, by the way, up on the top you put equals P, the first variable. But you pay the 95 cents every topping, so I put a T on this 95 cents instead of an X. So the equation can be, the situation can be represented with the equation 6.95 plus 0.95 T equals P. Okay. The load in pounds of a wheelbarrow is its own weight of 42 pounds plus each 4-pound brick that it carries. Okay. So we got 42 to begin with, and up top I put equals L, okay? And then plus, the operator, it said the word plus, so that's going to be 4, but it's every 4-pound brick. So I need a variable to represent how many bricks we have, and that's where the B comes in. So 4 times B. So it's 42 plus 4B equals L. Okay, the almond extract remaining in an 8-ounce bottle decreases by 1/6, I was supposed to say ounce, sorry, O-U-N-C-E. 1/6 of an ounce for each batch of waffle cookies made, okay? So I have 8 to begin with, but now it says decreases, so that'll be minus. Technically the line would be going down, but just keep it consistent because it's not going to matter as long as you put the plus or minus. So you're decreasing it by 1, by the way, put equals A. Okay, that's a variable we need to use at the top. You're decreasing it by 1/6 of an ounce for each batch, so I want to use B then for my second variable, my independent variable. This is the dependent variable at the top. So it's 8 minus 1/6 B equals A. Okay, a burst pipe has 37 inches of water, so we know we got 37 at the beginning, and that's W, so that's my dependent variable. I put equals W at top, and it decreases at a rate of 1.5 inches per hour, so decrease is minus 1.5, but it happens every hour, so then I use H as my independent variable. So it's 37 minus 1.5 H equals W. Bam. Okay, now last one. It says use the vertical line test to determine if you have a function. Vertical line looks like this. And you're going to draw a vertical line through each point, but the thing is, for it to be a function, your vertical line all your vertical lines that you draw, you're going to draw a bunch of them, can only go through one point. Okay, if they all do, then it's a function, but if they go through more than one, then it's not a function. Okay, so right there's a point. Go through it, just one of them. But right here, that went through two of them at the same time, so then we have a non-function. And as soon as one of my vertical straight up and down lines can go through 2 points, then it's not a function. Okay, and you don't have to do this, but if you label your coordinates, like that's backwards 1, so -1, and that's up 1, so 1. See right here, that's backwards 1, -1, and that's down 2, -2. The X is repeated twice with -1 and -1, so, but I don't need to label all the coordinates if I just know how to make a vertical line. And those points were what we call a bunch of discrete points. Okay, they're not connected; they're just discrete. Now the next one. Now you have a continuous graph. This is points that are connected. Make a vertical line through the graph. You only have to do one of them if it's just one whole graph. Okay, vertical line. How many times did that cross this little shape I made with the black marker? It crossed it once and twice. So again, it went through 2 points at the same time. So that again is not a function. Because it crosses here and here. So again, this vertical line here and here. So when it's a discrete graph, you just go line, line. As soon as the line crosses more than 1 point, you know it's not a function. Okay. Now, if it's a graph, you just make one line. If it crosses it twice, that's going to be a non-function too. Now let's go to the next one. Okay, we have another continuous graph. Make a vertical line. How many places did that cross our graph here? This little object I've graphed. Crossed it only once, okay? So it crossed it once and only once. And if you draw a vertical line, and you can draw the vertical line anywhere, okay? It doesn't matter. But anywhere I draw it, it's only going to cross once. Like right there's once, okay? Right there's once. It would cross it just one time, okay? In each place. So if it crosses just 1 point in each place, then it is a function because you don't have any repeated x values. Okay, and last one we got a line. So just make your own vertical line anywhere and ask yourself how many times does it cross it? It crosses it just once right there. Okay, just one time. So we have a function. Okay, now I will help you out here. Now, if I make a vertical line here, that's just 1 point. Okay, so we're good. Just once, just 1 point, just 1 point, 1 point, 1 point. So that is a function because I never go through more than 1 point at the same time with the vertical line. See, here would cross it twice, making it a non-function and so forth. Okay.